Okay, folks. So this is a new topic and a new series of videos that we have brought to you through my channel, Classic Quants. And in the next 5 videos, we will discuss about the simulation process, computer simulation, basically using Excel primarily. And this is a 5-part video series, and this is the first installment. But before we start, really, I would like to mention that this is a channel. This is the channel you are watching, Classic Quants, and I am in a process of making video series uh, specifically for the management science students and experts and enthusiasts. So you can find 3 playlists here. First one is about optimization using Excel. Second one is business forecasting, and the last one that I made here is about security analysis for investments. And let me tell you one thing, that these series of playlists are actually complete course content. That means there is no hidden agenda of attracting you towards any paid course content or material. This is the complete course content. So for example, if you go through all the videos of business forecasting or optimization using Excel, you are going to know the entire subject matter. So you don't need to refer to any other books or materials or course content or any notes or anything like that. So everything you can learn from this YouTube channel only. So having said that, my humble request to all of you is to please subscribe the channel, because you see the subscriptions are actually not growing, and with this it is very much difficult to keep this channel live and updated and remain motivated. So again, I would request you that if you feel that this channel is helping you or it may help others, like you know somebody else who will be benefited from the course content, then please share the channel with them, and also ask them to subscribe. Anyway, so let us come to the actual topic. So we were discussing simulation. So what is a simulation? Simulation means it is the representation of any real life problems uh, before the problem actually happens, or before some objective sample observations can be made. We are trying to predict or trying to make our own model of simulation, which will give us some output. And so therefore it is an imitation of the real life process. So the real life process is already going on, but due to some reasons we cannot actually analyze the entirety of the process, or it is not feasible to analyze the process as it is. So therefore we are taking the help of simulated environment and using computer programs to simulate the actual process. So third point written here is that it is very easy to create sample observations using computer output. So these things we will learn step by step. Just to mention here that if we are using computer programs like Excel, we will mainly use Excel here. So if you are using Excel here, or any other program for simulation, that can generate sample observations in seconds. So you don't have to wait for days and months and weeks in order to generate samples from the actual process. So that is the primary, one of the most pressing advantages of simulation. And so, like we already said earlier, we are not mathematicians or analysts. We are basically management scientists, students, experts, or enthusiasts of management science. And hence, our primary objective is formulating the simulation model using computer program, or more specifically Excel spreadsheet. And therefore we will limit our discussions on the theoretical premise, or will not confine ourselves too much into theoretical discussions, and our main objective will be to implement the model. That means implementation process is very important for us. Okay. So now, if you ask me why simulation, why should actually fundamentally we use simulation? So to understand this, let us consider an example. Say you are in a company working, and the company is launching a new product for a new market, and the company is also kind of new. So say a startup company launching a new product for a new market. So basically what I mean to say is you don't have any prior data or anything else, or actually nothing has already happened in the market, so that you can collect some data and predict, do some forecasting exercise or something like that. So if you talk about the model itself, then some part of the model will be actually controllable. Controllable. Controllable to whom? To the decision maker, that means you or the management basically. So consider this. Suppose a new product is getting produced and sold in the market, and what is the controllable factor? Simplistic, this is a very simplistic view of the actual process. Not much variables are present here. Just to illustrate the point, what is a controllable factor here? Selling price is a controllable factor. You can readily decide what will be the selling price in the market. The management will only decide, nobody else is there to decide. So that is your controllable factor. Some factors are also there which are not controllable. For example, the variable cost per unit, that is uncontrollable or not in your control. So we call this uncontrollable factor. Uncontrollable 1, 2, and 3. How much demand it is going to generate, you don't know. That is also uncontrollable. The fixed cost that is incurred, that means the plant and machineries and all other these costs which are fixed in nature, that is also uncontrollable. You may argue that to some extent this variable cost is under the control of the management, how much that cost will be, or management can initiate some cost cutting measure, cost control measures in order to make this variable cost low. All these things are true, but broadly, I am saying broadly, but just to illustrate that some variable costs, at least some part of it will not be under the control of the management. Similarly, some part, at least if not full, then at least some part of the fixed cost is not under the control of the management. And similarly, I think entirely the demand is also not under the control of the management. Again, you may argue that some marketing initiative, marketing advertisement costs, advertisement investments will boost demands. All those things are only complications and addition to these models. We are not considering all these aspects right now. We are keeping a simplistic view, right? So now, what is the output of the model? This is the output, that is the total profit. We call it TP. Total profit is the output of the model. So we have defined some variables. Small s is for selling price, small v is for variable cost per unit, capital F for fixed cost, and say q for demand. And this is the equation for total profit. So what is the total profit? Total profit is selling price minus variable cost into demand. This gives you the total contribution minus the fixed cost. You must have read these things in your break-even analysis courses, or if not, you can very easily understand that if you subtract the variable unit cost from the selling price, that gives you the unit contribution margin, and multiply that with the volume or the demand to get the total contribution, and then subtract the fixed cost from it to get the total profit. So that's it. So this is the model. Now still I have not answered the question why I am using simulation. So for that, let us consider this equation once again. Now for try to understand the complexity here. The equation itself is very simple. It is a simple equation. So somebody gives you the value of S value of small v, value of q, value of f, you can easily, very easily calculate TP. But the problem is here, small v, small q, small v, capital Q and f, these things are not deterministic. What does that mean? That means v will follow some distribution, say normal distribution, right? Then volume may also follow some other distribution, say uniform distribution. Fixed cost may follow some other distribution, say triangular distribution, something like that. These are all examples only. So first of all, the complexity comes from the point that these variables are not deterministic in nature, they are probabilistic in nature. So you cannot just input one value for v, one value for q, and just one value for f in order to calculate total profit, right? So another aspect of complexity is this. So what could be the possible questions that are we are trying to answer here? So if you have a particular value of s, remember I told you s is a controllable parameter. That means the selling price of the product in the market is a controllable variable. So suppose you decide a particular value of s, decision is in your hand. Anything, suppose $50, $50 will be the selling price management has decided. So if that is the decision, then what is going to be the average profit? This can be your question number one. What is the average profit that you can expect? Not only that, question number two is what could be the ranges of profit? That means the minimum or maximum value of profit, or even the variability in terms of variances or standard deviations. What could be that? So that could be your second question. Another question can be what is the chance of having losses? That means negative profit. What are the chances or probabilities of getting negative profit? That could be your question 3. So not only that, there can be many more questions like this. So see, the complexity is from two aspects. One is that these variables are not deterministic in nature, and another thing is we are not simply trying to answer any particular single question. So we may have multiple objectives or multiple questions to answer. So so then my question is, can this problem be solved using analytical process, analytically or mathematically? That means using mathematical models, optimization models. So what could be the answer? The answer is yes, definitely. You can develop very complex models, or you include all these variables, all this distribution into this equation, and maybe you try to solve some multi-objective optimization problem in order to answer these 3 or 4 questions. But the question comes here: is it worth doing such a long exercise or complicated exercise when we can do it easily using some other process? So here comes the use of simulation. In case of simulation, what we will do is we will carry out replications of this V, Q, F, and finally TP. So what is V? That means using replication 1, we will have one particular value of V, then Q and F, and finally using those values, we will calculate the total profit. And then there will be a second replication, and some other values of V, Q, F, and TP will be there. In this way we can have a lot of applications. And see, this is not a problem because we are using computer programs, so you can have 1,000 replications or 10,000 replications or 50,000 replications or 1 lakh replications, doesn't matter. So you choose to have n number of or multiple replications, and you can have these V, Q, F values and TP values calculated for all these replications using simulation approach. How to do that? We have not discussed this right now. We will discuss that after some time, but please understand the concept here. So all these replications, for each replication we will have one value of v, one value of q, and one value of f, and then using these three and this equation we will calculate the value of total profit for each replication. And now once this column is formed, let me change the color of the marker. So once this column is completed, suppose you are taking 1000 replications, so you will have 1000 TP values, and then you can probably calculate the average here, the range here, standard deviation here. So this is your average, column wise average, column wise range, column wise standard deviation, and then you are basically trying to answer or answering these questions individually. So also you see, now suppose you decided $50 of selling price for each replication. So for 50, for S is equal to 50, you monitor the answer to these questions, question 1, question 2, question 3. What are the answers? You are getting these answers here at the end of this TP column. So then you vary the S little bit, like from 50 to 40, then again monitor the answer to this question. You take a range of values for S, for example 10, 100, whatever you think is suitable, then try to answer, not try to answer, you will find these answers here. Every time you change this value, you will get the average, range, standard deviation updated. So you just note down these values. So see what is happening. For multiple values of your own controllable factor, that was S, you are getting these questions answered. These questions answered here. And now it is not very difficult for you to choose a particular value of S, looking at the answer to these questions. Which one will you choose? You will choose that one for which the best quality answers you are getting. So for example, maximum average profit you are getting for some, suppose for S equal to 40, you are getting the maximum average 40, average TP, minimum standard deviation TP. So if it is like that, then S equal to 40 is your optimal solution. And believe me, if you just replicate this, not 1000 times, but say 50,000 times, 50,000 times, or 100,000 times, which is very easy actually, not very difficult. Just you have to increase the number of rows in the Excel sheet. If you can do this, and you will do this actually, then the optimal solution, that means the optimal value of S, the optimal value of S, call this as S star. Suppose this is the optimal value of S. Optimal S. So if you are finding this optimal value using 100,000 replication, it will be very, 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 very close to the actual optimal solution that we were discussing here using the mathematical or optimization approach. So you increase the number of replication, you will get the optimal solution or the best solution from your simulation output, which is very close to your optimal solution. So that is the beauty of simulation process. Otherwise what we will do? So suppose you are not doing simulation, you try to do it manually by taking sample data without simulation. So what will you do? You will monitor every month. Suppose for first 1000 month you monitor for S1 is equal to 50, then next 1000 month S2 is equal to 40, then next 1000 month 30, something like that. and note the TP value actually happening in the market, actually happening due to your actual demand, due to your actual variable cost, due to the actual fixed cost. What is the actual TP that you are monitoring? And then you are taking averages or whatever, standard deviation, all these things you are calculating. So can you see the problem here? You are taking 1000 samples. That means 1000 months only for one value of S1, 50 only. Then you are taking 1000 months of data only for one value of S2, sorry, that is S2, which is 40. So how much time you will going to take in order to answer the questions or getting a proper value, optimal value, close to optimal value for selling price? It is very difficult. So even if it is not 1000, even if it is say only up to 10, so 10 months of data for s equal to 50, 10 months of data s equal to 40, 10 months of data s equal to 30, 30 months is gone already. So now only three types of data are there: 50, 40, 30. Out of that, maybe you find that 30, for 30 your question 1, question 2, question 3 are best. So then you select 30 as your optimal choice of selling price. Already 30 months are gone. Your data is also very short data, that means only 10 samples, so it cannot be reliable. And also you have tested only 3 possible values of selling price. So this is very difficult and almost impossible. And therefore, if you are using simulation, all these things can be done in seconds using Excel. That is the beauty of simulation. Okay. So now the types of simulation. Okay, I need to remind you that we are not doing any simulation in today's video. We are just introducing the subject, and at the end of the video, we will come to the Excel sheet to implement some Excel functions that we will see later on. Only implementation of the function, that part we will do in today's video. From the next video onward, we'll start building models. Okay, so this is also a part of theory. So what are the types of simulation approaches? One is your deterministic models. So what is that? Let us leave this aside. First discuss the probabilistic models. It is very simple. The model I have given you so far is probabilistic model. Why probabilistic? Because this V, Q or F, these had their own distributions. So they are not having any fixed value. They are following some particular distribution, and therefore it is not a deterministic model. So then therefore what is a deterministic model? Deterministic model is a model where the variables will not have any particular distribution. They will have fixed value. They will have fixed value. So you may ask that what kind of stupid thing is this? Suppose this is a model and these value are fixed. So why on earth I should use simulation exercise? Anybody can calculate TP value with fixed value of V, Q and F. So the answer is this. In case of deterministic models, the function or the model itself is not like this childish simplistic model. It will be a complex model. Sometimes it will be unknown models. That means only variables are there. I should not write this VQF. Variables, suppose x1, x2, x3 variables are there, and some output is there, and you don't even know the relationship between these variables, and also you don't even know whether these variables are correlated or associated or anything like that. You don't even know. And so what you will do is, what you only have is historical data. That means x1, x2, x3 values are there, and then corresponding output variable values are there. From there you don't know what is going to be the model. You are analyzing the past data in order to build simulation models. So please remember that when you are dealing with deterministic models, which we will not discuss here, we will only concentrate on probabilistic model. But for the theory sake, we are in deterministic models, such simplistic models are not used. Complex models or even unknown models are used. Okay, then what is discrete event simulation? See, suppose this can be best explained in terms of queuing. Suppose some arrival is happening, right? Arrival is happening. Customer 1 has arrived. Then after some time, customer 2 has arrived. Then after some time, customer 3 has arrived. So between customer 2 and customer 1's arrival, is anything else happening? No. So the events are happening, that means the arrivals are happening, right? Customer 1, customer 2, customer 3, these are the events that are happening. And in between these events, nothing actually happens. So if we monitor the sequence of the events, that means customer 1 arrives, customer 2 arrives, customer 3 arrives, and customer 4 arrives. In this way, discrete events formation, discrete happening of the discrete events. In this way, if you formulate your simulation model, that becomes the discrete event simulation. And then what is the continuous simulation? Suppose you monitor the time. Suppose in 12, then 12 and 1, 12, 2, and some flow is happening. Suppose some flow is happening. So even if you take a time point in between, suppose 12:005, suppose in that time point also some flow is happening. So the thing is that it is never discrete in nature. So the flow or the arrivals or whatever the process be is happening continuously throughout the time, and we don't have any other measures to formulate the simulation models rather than taking the time as the variable. That means every ultimately you have to do it in a discrete manner. So even if you take 12 and 12 1, in between there are in between times are there in between 12 and 12 1, but you cannot actually continuously monitor something, so some gap is always there. So you will monitor the time variables, time points, and for that the actual events will be monitored. But please remember that even if you are monitoring the time in a discrete manner, in between those time also there are time points where the actual process is going on. Okay, so that's it. Now let us understand another concept, which is the random variate generation, which is the most important concept here, actually required for model building. So in one line it can be said that the generating random numbers from given distribution is what is called is a random variate. So for example, this is a normal distribution and this is your mean, this is your mean, right, mu, and suppose this is your some point x value in horizontal axis, and this will be your cumulative distribution value fx, right? So now what happens is, in case of statistics or managerial statistics, if you are given a particular value of x, then you can calculate the value of fx. What are the methods? There are two methods. Basically, you can refer to the standard normal table, or you can use this formula norm dist x mu sigma 1. If you calculate this using Excel, then it will return you fx value. But in case of simulation, the situation is exactly opposite. That means here the fx value will be there, and from that fx value you are going to calculate x, and this x is known as your random variate. And what is fx? Fx is a random number generated from an uniform distribution between 0 to 1. So any random number between 0 to 1 will be your fx value. So what do I mean by any random number? I mean here is every time you do one replication. So remember we were talking about replication. The first column of the table replication, suppose this is number 1. For replication number 1 and for variable 1, suppose in this case what is your variable? First variable was which one? V, right? So the first variable was V, and therefore there will be a random number for V, and you have a particular distribution of V. Using this random number you will get a value of V, suppose V1. So how to get that value? Using this X. That means this random number will give you the fx value, and from that fx value you will get the x value. So what is the method? Method is either using standard normal table or using the norm inverse formula. So the norm inverse formula, the syntax is like this: norm inverse fx mu sigma. If you write this, this will give you the x value. So in our case, fx value itself is random number between 0 to 1. So therefore what is happening here is we are specifying the fx value, specifying in a sense for a particular replication and for a particular variable there is one value of fx. In the next replication the fx value will change, and accordingly the x value will also change. Again in the next replication the fx value will change, and again there will be a new value of x. Why the fx values are changing? Because we are using this rand double bracket formula. According to this formula, every time you type it you will get a new number between 0 to 1. That will be your updated fx value. If this seems a little confusing, don't worry. When we will start building models, this will be very clear to you. Okay, so now I have introduced the process for normal distributions. The same process you see here, the formula is written: random number mu sigma. If you insert this, you will get the x value, that means the value of the random variate. And for other distributions also you can calculate it in this way. Note carefully that in every case the random number function is always there. Why? Because this is your fx value. Fx value is your random number, right? So you calculate a random number between 0 to 1, that is your fx, and based on that fx you are getting x, which is the value of the variable. So I think this is clear now. Now we will go to the Excel sheet just to implement this formula and how it looks, just to see that. So let us come to the Excel sheet. So here are the formulas. For example, if it is an uniform distribution, two parameters will be there, a and b. Suppose a is 10, 20 and b is 20. So always remember the distribution parameters will always be given to you. So for example, this is an uniform distribution, right? So uniform distribution looks like this. So this is your a, this is your b. It becomes a rectangle here. If you can recall your study notes of uniform distribution, this is like this, and this is the entire area under the curve. which is equal to how much? This is equal to 1. Now, in the simulation process, what we are doing is we are just identifying some fx value. Suppose this particular portion of the curve. So this is your fx value, right? And correspondingly, we are trying to find this x value. So, what is your fx value now? Random number. Okay. So then what is your x value? See this formula, a plus b minus a into what? This random number, this one, right? Let me remove this clumsy things. So always see that the fx values are varying. That means the random numbers will always vary. If you want to vary this, you have to press F9. So every time you press F9 in your keyboard, this fx value will change, because this random function rand double bracket, this is a dynamic function. Every time you press the F9 button, F9 key in your keyboard, the random number or the fx value will change, and accordingly the x value will also change. Similarly for exponential, what are the parameters? There is only one parameters, lambda. Suppose this is 2. Again I am saying this parameter distribution parameters value will always be given to you. So suppose in our example variable unit variable cost was v, so it will be given to you that v will follow a normal distribution, say mean 10 and standard deviation 5, something like that. It can be other distributions also, just an example I'm showing here. So every time any variable introduced in simulation, there will be distribution and the parameters of the distribution will be given to you. So from the basis of that only you can conduct the simulation process. So again, what is your fx? rnd. And what is your x? See this formula, minus 1 by lambda into natural log of this random number, right? So again, if you press the F9 key in your keyboard, this will vary. Now note very carefully, I have not taken the same random number that I have taken here. In simulation also, this is very important. Please listen carefully. Suppose some replication, I have told this already, but again I am repeating this for clarity. So you have a variable v, right? You have another variable q, right? Another is f, right? So when you are using replication for v, suppose this is normally distributed, v is normally distributed with mean is equal to 10 and lambda, sorry, sigma 5. So what is the probability? Random number, then mu 10 5, right? This is your v value. So when you are calculating it for v, please understand this same random number will not apply for q. Q will have its own random number, f will have its own random number. So don't do this type of mistake that insert a column here, then write a random number and do is random here, then reference this this cell here, and then here also and here also. So that means what? This one random number is now applicable for 3. That is not the correct approach of doing the simulation. Every variable will have its own random number, and for that either open 3 columns for rn here or simply use the rand function in between the formula. So that will help. and that is the reason precisely I have used the fx formula or the rand formula twice and not referenced this is wrong. Okay, so this is for exponential. So how will the curve look like for exponential distribution? It is something like this, I think. Exponential, poor drawing, doesn't matter. And so this will be your fx value, this is your x value. So using rand you are getting fx value, and then it is returning you the x value using this inverse function. Okay, and I believe this is clear. Just the normal is you have already seen. Two parameters are there, mu and sigma. Suppose mu is 10 and sigma is 5, and fx is what? Again rand. And what is x? See, it is given here, norm inverse rand, then mu, then sigma. So this is it, right? Now another important thing, it may so happen sometimes that you're getting x values. It is very natural that you are getting these x values in decimal places, because you are getting a random number in multiple in decimal places, and accordingly x values are also coming in decimal places. But suppose this variable is your demand. Can you get demand in terms of decimal places? No, it will be integer like so. Therefore it is sometimes it is important that we use an int function like this. The entire thing will be inserted into an int function. This will make sure that the value becomes integer. Okay, in this way. So actually this may be 3 point something. So this integer command or integer formula truncates that to 3. So in this way you will write this formula. We have not built the model so far. We are just writing the formula in Excel. And when we will build the model, we will again write this formula, but now little precisely and little in one single row actually. So my humble request to all of you is, please watch this video carefully, and if you are very new to this subject or even have not touched simulation at all in your career or in your course content, then please practice this formula once using an Excel spreadsheet before you are ready for the actual simulation model building procedure. So that's it, folks. This is the end of this video and the first installment, and please wait for the next video where we will develop the simulation model. So in the first video there will be a simple model so that you don't feel any anxiety or any problem. So until then, goodbye and thanks for listening.